Today we're going to be looking at the graphs of sine and cosine. So the x-axis, the inputs will be angles, and then the y values, the outputs, will be the sines of those angles, the ratio, the opposite over hypotenuse for those angles. And so we'll just look at the quadrantal angles. That'll be enough for us to see the pattern. So we'll take a look at each of those on the unit circle and see what their coordinates are. Sine will be the y coordinate on the unit circle. Cosine will be the x coordinate on the unit circle. So for the angle 0, we've got 1 comma 0, so our sine is 0. And then for pi over 2, we're straight up, 0, 1. So the sine is the y coordinate, the 1. Over here, we've got negative 1, 0, 0, straight down, 0, negative 1. So the sine is the negative 1. And then 2 pi brings us a full circle. We're back to where we started. So we're back to this point here, a sine of 0 again. And so that's why we only have to go from 0 to 2 pi, because once we go past 2 pi, we're going to start repeating. We're just going to keep going around the circle, around and around. And so if we plot these points here, we'll have a point here. Pi over 2 is right in the middle there. And so we'll have a point up here, there, down here, and we'll end right there. Then again, it's just going to keep repeating. And so we'll just keep doing the same pattern over and over and over again. It will be curvy. It will not be linear. You could think about by the time you reach pi over 6, you're already at a half. So pi over 6 is a pretty small angle. You're already at a half. And so then it's going to take more angles to get that other half there. It's not a constant rate of change here. It's going to be curvy. So just keep curving that same way. And then cosine is going to be something similar, where it's going to kind of bounce around between 0, 1, negative 1, that kind of pattern repeating forever. And so for cosine, it's a little bit funny. The y coordinates on the graph are the x coordinates on the unit circle. So for the angle 0, the x here is 1, and so the y on the graph is going to be 1. So we'll have this point 0, 1 right there. And then pi over 2, we've got 0, and then negative 1, and then 0, and then back full circle 1. And so as we sketch this graph, and these graphs just kind of bounce around between 1, 0, negative 1, 0, 1, back and forth, up and down, over and over again. Again, this one will be curvy. It'll look something like this. It's just going to keep repeating that same pattern on forever and ever and ever. And so if you still have your yellow sheets that we used in class to fill out all the base graphs, you might want to add these onto your yellow sheets here so you can see what a second repetition the graph would look like on the left side of the y-axis, how it would just keep repeating onto the left side. So again, these graphs are very, very similar. And so one thing you might want to make sure that you keep straight is where they start. As long as you start in the right place, then usually you can keep the pattern going correctly. So sine starts at 0 because sine of 0 is 0, and cosine starts with a y of 1 because cosine of 0 is 1. Keep those straight, then you can just kind of follow the pattern and bounce around on the graph there. We can keep in mind that the scale of the graph is pi over 2. And then we're going to talk about something called a period. So things that repeat regularly, we call them periodic. And so since these keep repeating on forever, we call these periodic functions. The period is the length of one section of the graph. So if you look here, since we had this section right here, 0 to 2 pi, one section of the graph, we call that one period. And so we say the period of the graph is 2 pi, because that's how long it takes before the graph starts repeating. There's something else we talk about for trigonometric graphs. We talk about what we call the amplitude. So the amplitude is the height from the center of the graph to the top of the graph. So our amplitude here was 1. We'll go from 0 up to 1 there. And so we've got amplitude and period. Sometimes we talk about frequency as well. Frequency is just 1 divided by the period, how often that occurs. So if you think about amplitude and frequency, You might know that's the two different types of radio frequencies or radio stations that we have. We have AM and FM, amplitude modulation and frequency modulation. Sound waves are actually sine and cosine graphs, sinusoidal graphs, trigonometric function graphs. These things show up all over the place. Sound waves, electricity, all kinds of stuff. And so they're very, very common. If you go into any kind of applied field, science field, you'll work with these a whole lot. And so we're going to do what we do with all those other base graphs we put on those yellow sheets, where we're going to need to know these base graphs really, really well, and then take those and do some different transformations. And so there's three transformations that we'll look at today. We'll look at changing the amplitude, changing the periods, and then we'll also do some vertical shifts. So if we take a look at this example here, if you put a constant in front of the function, you're taking the whole function, you're taking the y values, and you're multiplying by that number. So this number out front is going to give you the amplitude. The amplitude is always positive. So for this one here, normally cosine, the graph would start up at 1, but then we take that 1 and we multiply it by 0.75. And so now we're just going to start at 0.75 there. It's just going to take this graph that we had, it's just going to vertically shrink it just a little bit. So instead of going between -1 and 1, it's going to go between -0.75 and 0.75. Now inside here, though, we're changing the x values, the scale of the x-axis. So before we had to get to x was 2 pi for the graph to start repeating. So now what we're looking for is what x value would make us be plugging in 2 pi into the cosine function. So we want to look at, for the periods, we want to look at when does 2x equal 2 pi. And so that's going to be when x equals pi. So for this one, by the time that we just get to pi, it's already going to start repeating. Because when x is pi, we're actually plugging in 2 pi into the function. And so we're already going to be plugging in that full circle angle. And so we'll already start getting repeating values there. So the period, the length of the graph here, one period, is going to be up to pi right there. And so periods always start and end at the same place because that's when it's going to start repeating. So we know at pi, we're going to have another point up there at 0.75. And then these graphs just have 4 points from after you've done the first one there's 4 more points to go. So once you know your period, just divide that into 4 pieces there. So if we end at pi, then the first point that I need is going to be at pi over 4, right there. And so then you can just kind of bounce around here. If you're at the top of the graph right here, then your next point has to be in the middle, to 0 here. And then if you've gone kind of top, middle, next thing is bottom. And again, it's not going to be -1 now. Now it's going to be up at -0.75 because we've changed this y-axis values that we need here because of this vertical shrink right there, the amplitude change. All right, and so then now if we're at the bottom of the graph, the only place we have to go is up. So now we go back to 0, and then we're right there. So that's one full period of the graph. If you needed to sketch more periods, you would just keep going that same pattern. At the top of the graph, we go to the middle there, and then down to the bottom, and then back up. So there's another period. You could do the same thing on the left side of the y-axis. Here's the top of the graph, just going backwards. Now we'll go to the middle, and then down to the bottom right there, and then back to the middle, back up to the top. So now this one I've sketched 3 periods of the graph. One period was up to pi, and then we've done it before. Notice how these arrows at the end curve back down. One thing that's important to note about the functions is that they do have a maximum and a minimum y value. They're what we call bounded above and below. There's only so high going so low. So these arrows right here, it's got to curve back down because 0.75 is the highest y value you'll ever reach. It can't go higher than that. So then just one more graph that we'll look at here. This one's got a vertical shift, just like all the other functions that we've seen. If you stick plus a constant at the end of it, it's going to shift the graph up. And so if you think you have a pretty good idea about what that might look like, you could try sketching that all all in one shot, but it's often helpful to take these and sketch them without the vertical shift first. So first, just sketch that graph without the +1 there. And then after that, you can just take every point and shift it up 1. We know that +1 is just going to move every point up 1. So I'll do that. If you think you know what it's going to look like, you could try sketching it now in one step. And then if you're right, then you can go ahead and give that a try. And if not, then maybe try my method here of 2 steps. So this is a sine graph. So the cosine graph started at the top at its maximum value. Sine graphs start at 0 at the origin there. And then notice we've got one other transformation here that we haven't seen yet. In addition to changing the amplitude, in addition to the amplitude being from 0.5 to -0.5, our amplitude is 0.5, so the graph is going to bounce between those two y values. We've also got a negative there, and so the graph is going to be reflected about the x-axis. So instead of the graph going up here like it normally would, now it's going to go down. Also, we didn't change our period, so we're going to be ending at 2 pi here. The period hasn't changed, so we're still going to go from 0 to 2 pi. And so that means the scale for the x-axis is still going to be that pi over 2, or the base graph. The x-axis isn't going to change from our base graph. What's going to change is that instead of bouncing between -1 and 1, we'll bounce between -0.5 and 0.5 because of that constant out front. And then because of the negative, it's going to flip upside down. It's going to reflect. Instead of going up, I'm going to go down. So I'll go down here. Now if I'm at the bottom of the graph, I go back to the middle at 0. And then keep that pattern going up to the top there. And then that's where I end. So without the vertical shift, the graph looks like this. And so then, to get the graph that I wanted, all I have to do is do that vertical shift. Take every point, move it up 1. So this point goes up here. That point goes right there, -0.5 plus 1, +0.5. And about there. And then 0.5 plus 1 is 1.5, looks like right there. And then that point goes there. And make sure your period ends where you started. Make sure your arrows don't go too far. They can't go past this maximum value or that minimum value right there. But if you have any trouble with these, I recommend just maybe try playing around with some of them in your graphing calculator or on Desmos. Try putting a number out front, try putting a negative, try putting a vertical shift at the end, try putting a number inside the function next to the x, and just play around with some of them and get to see what these different transformations look like.